Hello everyone, welcome to the class once again. So after learning the concepts on work, energy and power, I believe that you will be ready to practice questions. In today's class, I'll be talking about JEE main pattern question. In JEE main, the questions are of multiple choice and each question will be having one option as the correct answer. The level of difficulty is quite moderate. They're not too easy, not too tough, but you can think that if I rate it at a difficulty level, I will say that it's 60 to 70% difficult. Let's go ahead and let's go with the practice of JEE main pattern question in this chapter of work, energy and power. Let's go with the first question of the day. The first one, when a rubber band is stretched by a distance x, it exerts a restoring force of magnitude F is equal to ax plus bx square. Where a and b are constants, the work done in stretching the unstretched rubber band by L is a al square plus bl cube, b half al square plus bl cube, c al square by 2 plus bl cube by 3, and d half bracket al square by 2 plus bl cube by 3. So you see that it's given that it is exerted by a restoring force of magnitude F equal to ax plus bx square. See, when a rubber band is stretched by a distance x, if you take the natural length of a rubber band, you are going to stretch it with a length x. It says that it exerts a restoring force. Now if I make the diagram, how will it look like? See, let's say this is the rubber band. This is the rubber band. Now if I stretch it, suppose I stretch it through some length. It's given that if we stretch it through some length x, then it says that the restoring force that is acting on it, that is ax plus bx square. So it depends upon the distance x. It's not constant. Now we need to find out, let's see, the work done in stretching the unstretched rubber band by L. That means on stretching we have to do some work. Let's see here. If I stretch this rubber band, I have to do some work. I have to overcome the restoring force that is actually trying to pull back the rubber band to its natural length. That means I have to apply a force that will be just opposite to this restoring force. That means we should apply an F external. Now to move it slowly, to pull it slowly, I should apply the F external that should be equal to the restoring force. So that will be equal to ax plus bx square. Again, I believe that you must be remembering the concept of potential energy. So if we stretch it through a very small length, that is dx. If we stretch it through a very small length, dx, so the work done in stretching by this external force, that will be small work done, dw, that will be f dx, and that will be equal to ax plus bx square, and dx, this will be the small work done. Now what about the total work done? For total work done evaluation, we need to integrate both the sides. So for total work done, I am doing the equations here. That will be integration of dw, and that will be integration of ax plus bx square dx integrated ax plus bx square dx, and we need to integrate it from its natural length, that is x will be 0, and you need to stretch it through length capital L. So this will be 0 to capital L. So for 0 to capital L, see what we need to do, we need to put up the integration. Let me solve the integration properly here. See that this is different, and let us go ahead. You will get here ax square by 2 plus bx cube by 3. This is what you are going to obtain, and put up the limits 0 to capital L. So finally you will be getting al square by 2 plus bl cube by 3. This is the method that you have to actually use and solve. Let's see here the option that you will be obtaining, that will be al square by 2 plus bl cube by 3. Option number C is the correct answer. So what do? Take note for the entire question and solution. I will start from the other end. Okay, I believe that you would have understood how to solve this question. I like that you quickly see how we have solved it. Just have a quick look on all steps of how we have solved it. I believe that you would have taken note of it entirely. Let's go ahead with the next question, and before that, just let me clear the board for you all. Let's go ahead, and I'll just be ready. Now here comes the next question of the day. Question number 2. If W1, W2 and W3 represent the work done in moving a particle from A to B, point A, point B, along 3 different paths, 1, 2 and 3, 1, 2 and 3 respectively, as shown in the gravitational field of a point mass small m. So we have this gravitational field of point mass small m. Find the correct relation between W1, W2 and W3. This is a previous JEE question. So see here, we have to find out how they are related, whether this relation holds, or they all are equal, or this relation holds, or W2 is greater than W1 is greater than W3. 3 different paths, and the particle is let to move in the gravitational field of a point mass small m. Now gravitational field is a conservative field. In a conservative field, we know that work done is independent of the path adopted. So I'm writing some points. Gravitational field we are talking about, that is independent of, gravitational field is independent of path. Sorry, it's independent, the work done is independent of the path adopted. It's actually conservative field. Gravitational field is conservative field. This is what we need to know. It's a conservative field, and it's work done in a conservative field. We know that it's independent of the path adopted. So whether you move along this path, whether you move along a straight line path, or whether you move along a curve, it doesn't matter. The work done while moving from point A to B, that will be equal in all the cases. So option of B holds. Easy question, you should know the concept, you can easily take this answer in the JEE examination. Let's go ahead. Let me rub it. Now the next question of the day we have question number 3. A force capital F is equal to minus k yi cap plus xj cap, where k is a positive constant, acts on a particle moving in the xy plane. Starting from the origin, the particle is taken along the positive x-axis to the point a, 0, and then parallel to the y-axis to the point a, a. The total work done by the force F on the particle is option number A minus 2ka square, option B 2ka square, C minus ka square dka. First of all, if I talk about the path that is adopted, and this force is, you see, it's F is equal to minus k yi cap plus xj cap. First of all, let's talk about the path that has been taken. So if I talk about the path that has been taken, this is the y-axis, this is the x-axis. It is taken from, first of all, positive x-axis to the point a, 0. Starting from the origin to a, 0. So we start with first point here, that is 0, 0. It moves to second point, that is a, 0, and then it moves parallel to y-axis. So let me show you all the line parallel to y-axis. This will be the line, and this point they are talking about, that is a, a. Point number 3. A, a. That is the final point where the particle is reaching, a, a. Quite obvious. It moves from this path 1 to 2, then 2 to 3. This is how the path is actually shown. And then parallel to y-axis to the point a, a. So I have shown you the path. The total work done by the force F on the particle is, we know that work done is equal to F dot R or F dot X. Here I will be talking about work done is equal to F dot X or F dot R. That will be most appropriate term, F dot R. Now you see here, at any point if we talk about, if I write the force as this, F is equal to minus k yi cap plus xj cap, and if I talk about dr, see what I need to write down. F is equal to minus k, F is equal to minus k, and here we have yi cap plus xj cap. This is what we need to show, and r vector I have shown you here. If I talk about, actually I should write here small work done. We need to integrate actually. I should write small work done, that should be equal to F dot dr. Now if I need to write down again here F dot dr, see what we need to do. First of all, we have to integrate accordingly. We have to write down how this position vector that I have shown, dr vector, and how this both can be, we can actually do dot product and what we are going to obtain. So what you do, I will request you all to take note here, and I will switch on with the other part of the board. Take note till here. Okay, now what I wanted to show you all, you see this curve. First of all, the path has been shown this. If I talk about the initial point and final point, and if I join them, this is the initial point and final point of its motion. Now dr vector that I was talking about, at any time if I write down dr vector, that can be written as minus k yi cap plus xj cap, and dr can be written as actually dxi cap plus dy j cap. Take dot product of both of these. See what we are going to get. We will be getting here, and again we have to integrate also, so I will writing here minus k y dx plus x dy. I hope that this would be clear to you all of how we have got this minus k y dx plus x dy. Now you see here, this term can be written as, I will write this term in a different way, minus k, and here we can write this as differential of d of xy. You see, you will get y dx plus x dy. If you open this, you will get y dx plus x dy. So we can write this differential of this xy term. This is actually small work done. The total work done will be integration of this dw, which will be equal to minus k integration of dxy. Put xy limits. You see the initial point and final point. Why did I show here? Initial is 0, 0, final is a, a. Final is a, a, that you can observe. So I'll put the limits 0, 0 to, and here we have less space. Let me use other point. Let me use at the top part of the board. Work done is equal to integration of dw is equal to integration of 0, 0 a, minus k, and here we have dxy. So you will be obtaining this as xy. So this will turn out to be minus k xy. Two limits together we need to put for x and y, and both are same, 0 and a. So the final result that you will be obtaining, that will be equal to minus k a square. This is the final work done. Let's check the option that we will be getting. Option that matches, that is equal to minus k a square. The option number C is the correct answer, minus k a square. Now in this problem, actually what a student actually feels difficult and what tricky, he thinks that now he is unable to solve after this step. And second thing, he thinks that if the path is given in this way, how to solve it? This is what the trick actually is hidden in this question. Now one thing I would like to you all, from you all, that what you can do, you think that if you try to find out what is the work done while it moved from this point 1 to 2, try to find out, because there is no y coordinate during its displacement. Try to find out, and then you try to find out the work done while it is moved from 2 to 3. You will be seeing that the work done that you are going to obtain, that will be same as minus k a square. Do that method on your own. I'm leaving it up to you because that's an easy one, but that's actually lengthy. So we have did this one, is a short step, short method, and easily we can solve this problem by this method that I have shown you all. Let's go ahead with the next problem. This was a good problem. It's a previous year problem. I hope that it will be very much helpful to you all. Now let's proceed with the next one. Before that, just let me clear up the board for you all. The next one that we have, question number 4. Just a minute, I will request you all to just have a look on this question number 3 once again. I will start with question number 4 because I have a problem in this working of this. So start with, just read the question number 3. So I believe that you would have read this question number 3 once again, and I'll switch on to question number 4. A uniform chain of length capital L and mass capital M is lying on a smooth table, and 1/3 of its length is hanging vertically down over the edge of the table. If G is accidental to gravity, the work required to pull the hanging part onto the table is A, mgl, B, 1/3 mgl, C, 1/9 mgl, and D, mgl by 18. I believe that you can easily frame out the diagram in your mind what this question is depicting. So what I'm going to do, I'm going to draw the diagram that's actually clearly we can understand from the statement of the question. It says that uniform chain, mass M, rests on a smooth floor, a smooth table actually. 1/3 of its length is hanging vertically down. So if this is the table, 1/3 of it is hanging. This is the chain. 1/3 of it's hanging. Now see here, this total length will be L by 3. this part, center of mass will be somewhere here. Try to see, I'm marking this as C, and it will be at a length of L by 3 by 2, so L by 6. This is 1/3 part, its mass. If this is small m, that will be m by 3. Quite easily we can find out m by 3. Now it says that the work required to pull the hanging part on the table. So you can think that you will be actually lifting a point mass from this point on the table. So that will turn out to be work done will be equal to increase in potential energy, that will equal to m g h. M is m by 3, then g and h is L by 6. So 1 by 18 mgl. This is the answer for this problem, 1 by 18 mgl. So the resultant, option number D, is the right answer, that is 1 by 18 mgl. I believe that you would have understood how to solve such kind of question. Good question, previous year question this has been asked. So this is how easily you can solve this question. The next one, we have question number 5. A body is moved along a straight line by a machine delivering constant power. The distance moved by the body in time t is proportional to a t power half, b t to the power 3 by 4, c t to the power 3 by 2, and d t square. We know that. Now what is power? Power is equal to work done per unit time. So let us go ahead and without taking more time, let us discuss the solution of this problem. Power is equal to work done per unit time. We can write work done is equal to power into time. The work done is increase in kinetic energy. So we can write half m v square is equal to p into t. Quite obvious. Now you see here, we can easily write that v is proportional to t to the power 1 by 2. Not a problem. I can, because power is constant, mass will be constant, 1 by 2 is constant. And v square, so I have taken under root, v will be proportional to t to the power 1 by 2. Easily you can make out. If not, pause the video, just check this equation. You will get how we have got v is proportional to t power 1 by 2. Now v is ds by dt, proportional to t power 1 by 2. Now ds is proportional to t to the power 1 by 2 dt. So just to integrate both the sides, ds I am just integrating, rest constants will not be considered in this one. So you will be obtaining s will be proportional to 1 by 2 will come in the 1 plus 1 by 2, it will come in the denominator. So that will be 3 by 2, so that will be 3 by 2 I am writing here. This t to the power 3 by 2 you will be having here. So this displacement is proportional to t to the power 3 by 2, that is what we can make out from the equation. So s is proportional to t to the power 3 by 2. Option number C, right answer. That is what we can infer from all these steps that we have taken to solve this problem. Easy problem. We have actually changed how the equation looks like. Power equals to work by time, work equals to power into time. Right now I have solved. You must be thinking that it's very easy problem, but when you solve it on your own, you find that it will be difficult for you all to actually reach on to this step, how to actually frame such equations. But with practice, you will be actually understanding how to always easily make out equations from some given equation. So I believe that this class is very much helpful for you all in solving JEE main pattern question. 6.1. A particle is displaced through 3I cap minus 2j cap plus 2k cap meters under the influence of a force minus I cap plus j cap minus 5k cap Newton. Calculate the work done. A minus 15, B minus 20, C minus 25, D minus 30. Displacement is given, force is given. Easily we can solve it, not a big problem. Work is equal to F dot R. Both are provided. F is given minus I plus J minus 5. And the displacement vector, that is given as 3I cap minus 2j cap plus 2k cap. This is what that has been given. This is dot product we need to do. Minus 3 minus 2 minus 10. I believe that you are remembering how to do dot product. This is how you will be doing. So you will be getting minus 15 joule as the right answer. Minus 15 joule, that is the work done. Let's take the option. Clearly option number A is the right answer. So let's, without taking more time, we will be solving the next question. Prior to that, just let me clear up the board. Now let's go with the next question of the day. Question number 7. A bullet of mass 100 gram moving with a velocity 240 meter per second hits a target. After passing through the target 10 centimeter thick, it continued to move with a velocity of 160 meter per second. Find the average resistance offered by the target. A 12,000, B 14,000, C 16,000, D 20,000, all in newtons. We know that change in kinetic energy, that will be equal to the work done by the resistive force. Now see here how we need to do. Change in kinetic energy is equal to work done, and change in kinetic energy will be half m. Now we will be talking about initial kinetic, because the kinetic energy is reduced. So I will be actually subtracting initial kinetic energy minus final kinetic energy. That will be actually loss in kinetic energy. So 240, or let me write down first entire equation, half m final velocity whole square minus initial velocity whole square, which the variables have their usual meaning. Work done, F average into D, the displacement that has occurred in the block. Put up the values. Half the value of mass m that we have, that is given as 100 gram. So you can use 0.1. Final velocity, sorry, this will be initial velocity because final velocity is small. So I told you I'll be taking the difference, actually loss in kinetic energy. Initial velocity is 240 whole square minus 160 whole square. F average we need to find out, and it goes for 10 centimeter inside the block. 10 centimeter thick, after passing through the target 10 centimeter thick. So 10 centimeter thick, so we have to use D, that it has moved 0.1 meter. Now you see entire equation you have. 0.1 can be cancelled out easily, you can make out. Now here this term can be easily evaluated. You will be finding that F average will come out to be 16,000 Newton. I believe that the calculation portion can be easily done by you, which is quite easy to solve from here. 24 whole square and 16 whole square you have to use. Let's go ahead. Because 24 whole square is 576, I believe that you will be knowing that and you can easily solve this. The right answer is option number C, that is 16,000 Newton for this problem. Now let's proceed with the next question without taking more time. What power must be developed by an aircraft engine to raise it to an altitude of 1 kilometer? If the aircraft weighs 3000 kgf, that is kilogram force, and the time of ascent is 1 minute. Power we require. First of all, you see here, to raise it to an altitude of 1 kilometer, its weight has been given 3000 kilogram force. You see here, this is the mass that has been provided as 3000 kg. You have to lift it through a certain height. This height is given as 1 kilometer, that is 1000 meter. Power we need to find out. Power is what? W, work done by time. Now understand, next thing, W will be what? mgh, the increasing potential energy. So that will be mgh divided by time. Put up the values. Mass is 3000 kg, g is 9.8, height is 1 kilometer, so multiply here 1000, divide by time, that's 1 minute, so 60 seconds. I believe that from here you can easily solve it. You will be finding that how you can easily solve it. This will go 1 0 to 1 0, you can cancel out. This will go 50 times. I will be using the term which I have cancelled out. 50, now you can easily do this. 9.8 into 5 is 49, and you will be having 490, and you multiply by 1000, so this will be 490 kilowatt. Let's check the responses. 490 kilowatt. Option number A is the right answer. Remember the W in watt, kilowatt is actually in capitals. Here it's shown in smalls. Don't worry, it will be in capitals. Kilowatt, both K and W are in capitals. Easy question. I believe that you would have understood how to solve this. Let's go ahead with the next problem of the day, the 9th one. Before that, just let me rub this options correction. Question number 9. The string of a pendulum is 2 meters long. The bob is pulled sideways so that the string becomes horizontal, and then the bob is released. What is the speed with which the bob arrives at the lowest point? Assume that 10% of the initial energy is dissipated against air resistance. Take G equals to 10 meter per square second. A 2 meter per second, B 4 meter per second, C 6 meter per second, and D 8 meter per second. It says that a pendulum bob you have taken, you have made it horizontal. So the situation will be somewhat like this. Pendulum bob is initially here, you have made it horizontal, it will be here. This length is given as 2 meter. Check it. It says that the string of pendulum is 2 meter long. The bob is pulled sideways so that the string becomes horizontal and the bob is released. Now if you release this bob, what will happen? It will come down, all its potential energy will be converted into kinetic energy, but 10% of it is lost. The potential energy that it is possessing at the topmost point, that is equal to mg into height, that will be L. The kinetic energy at the bottommost point will be, because 10% is lost, so it will be only 0.9 times of potential energy at top. Because 10% is lost, so 0.1 times is lost, 0.9 of potential energy will be only left with it. Assume that 10% of the initial energy is dissipated against resistance. So we need to find out what the speed with which the bobs arrives at the lowest point. So now if I write, if the speed that is possessing here, that is V, so half mv square will be equal to 0.9 times of mgl. The term that will be cancelled out. Let me quickly make it which terms we have to use. M and m is cancelled out. Now easily you can solve out for the value of v square. V square comes out to be 0.9 into 2, this 2 has gone here, G into L, G is 10, L is 2 again. You can see that V will come out to be 3 into 2, 6 meter per second. Solve it, you will be getting V as 6 meter per second. Let's check quickly the option that we have. Option number C is the right answer. 6 meter per second, that is the right answer for this question, question number 9. So you should have the understanding how to solve such kind of question. Work energy power, we have used the concept of actually conservation of energy at the twomost point, and we have actually some energy is lost, so I have used that point also. This is what you have to keep in mind. Next question before that, just let me clear up the board. Let's go ahead with the next one. Question number 10. A gun whose barrel weighs 450 kilogram force fires in a horizontal direction. The weight of the shell is, this is weight, don't worry, it's WIT, the weight of the shell is 5 kilogram force and its initial velocity is 450 meter per second. When the shell is fired, the barrel recoils at a distance of 0.45 meter. Determine the mean braking force developed in the gun's counter-coil mechanism. First of all, let's try to find out what speed with which the actually gun recoils back. So we can use the law of conservation of momentum. Using law of conservation of momentum. It's a gun recoil case, we can easily find out the recoil speed. Now let's say the mass of bullet is small m, its speed with which it was projected, that is u, mass of barrel is m, its speed is v. So v will be actually equal to mu divided by capital M. See what that will come out. Mass of the bullet that has been given as, when the shell is fired, you see a gun whose barrel weighs 450 kilogram force fires in horizontal direction, the weight of the shell is 5 kilogram force. So weight of the bullet is 5, The weight of the gun is 450 multiplied with the speed with which it was fired. The weight of the shell is 5 kg force and its initial velocity is 450 meter per second. So let me write here 450. You can easily see the velocity with which the gun will recoil, that will come out to be 5 meter per second. Quite easy. Next thing, when the shell is fired, the barrel requires a distance of 0.45 meter. Determine the mean braking force developed in the gun's recoil mechanism. That is what we have to find out. We have been provided with the distance with which the gun recoils back. If I show you, the gun is here. If I show you this, the distance with which it recoils back, this is given as 0.45 meter. This is what that has been provided to us. So what you do, take note of this entire part of the solution. I will start at the other end, take note of the solution. So I believe that you would have already got the idea how to solve it. I have shown you the recoil distance of the gun. Now you see here, the mean braking force is asked. We know that the kinetic energy that the gun will be having, that will be half mv square, and this will be F braking force into distance that would be traversed. If we talk about the mean braking force, we have to multiply with distance, work done, that will be equal to kinetic energy of the gun. Put up the values, half, mass is 450 kg, v square that we have evaluated 5, force that we need to evaluate, the distance that it has moved back, that is 0.45. We can easily solve it. Now see, this will go 1000 times, and now you will be getting F, that will be equal to 12,500 Newton. Let's check with the answer. The option that is matching, that is option number C, 12,500 Newton. So after this problem, after all these problems that we have practiced today, what I will want from you all, don't be dependent on these 10 questions. You have seen, you have understood the method that we have to apply. But do practice on your own. Unsolved questions you need to practice for your own betterment and for your own improvement. So just what I want you all, I believe that you would have understood all these problems, and keep on practicing on your own, and I will meet you all in the next class. Till the time, do catch me in the next class with the next topic, and I will be there taking you all with the further improvement in your concept. Till the time, thank you everyone for watching here.